Hi, SOUMABHA, how are you?
Yes, sir. Yes, sir. I'm doing fine.
Great. So, SOUMABHA, did you write JEE?
I wrote JEE mains and I didn't give JEE advanced.
Okay, were you qualified? Write it?
Yeah, I was qualified. Yeah.
Okay. So, why do you want to pursue mathematics?
Because I have a keen interest in like the topic calculus. I like it the most, and uh, mathematics is something that I want to continue up to till the rest of my life because I find it very interesting. Apart from that, um, the problems, solving problems, it actually like what can I say? It keeps us motivated. On sort of it gives us motivation to uh, the solving some practical problems in our daily life. It gives us motivation, confidence. That's it. So
So, what are your areas of interest, SOUMABHA? Hmm.
I like calculus. Apart from that, combinatorics, I will say, and number theory.
Okay, great. So, SOUMABHA will start with a simple question. Can you define the point of inflection?
Okay, so a, a point of inflection is such a point where the when a curve, a graph of changes is concavity, like it is becoming from concave to convex or convex to concave. It is such a point, and if the function is twice differentiable, then it will be the value of twice differentiable at the point of inflection will be zero.
F double dash x is going to be 0.
Yes, yes. If double dash x at that point is going to be zero if it is twice differentiable.
Can it happen that at point of inflection, F dash x is not defined?
No, sir, it cannot happen because it may happen that f dash x is not defined at the point of inflection.
Okay. Can you give an example?
Like I can sketch a graph such that that at the point of inflection it will be a sharp corner, but it changes its uh, concavity at that point. So it is the point of inflection, but as it is a sharp corner, there won't be the at that point it won't be differentiable.
Something like this, that f dash x does not exist, but the concavity is changing.
Yes, sir.
Hmm. So that means f double dash x should exist is not a condition for a point of inflection.
Yes, sir. It is not a condition, but if it exists, then it will be equal to zero.
Okay, so let us talk about this graph. Right, so I'll draw a random graph. So something like this. So let's say this is a point where the concavity changes. Okay, but again, it has a vertical tangent. Let us also assume this is a vertical tangent. Right, so first of all, would such be point be a point of inflection? Yes or no? Hmm.
Yes, it will be a point of inflection.
What can you say about f dash x and f double dash x?
If dash x will not be defined because there will be a vertical tangent not defined,
And what about f double
and
dash x? Will it be 0?
if double dash x, it will be zero.
So this is a point or a graph where f dash x is not defined, but f double dash x is 0.
Yes, sir.
Uh, SOUMABHA log of 1 plus x expansion. Can you derive?
Like from the Taylor series expansion.
How do you know that?
No, sir. I actually have read the theorem, but okay,
Okay, no issues. The question is this series defined for large values of x? maybe 2000.
Sir, I think it is defined for larger values of X.
Okay, I think for that, you should know how it is derived and if there are any approximations, any conditions which we make in the expansion of log of 1 plus x to answer this question. But again, let me tell you, it is not defined for large values of x. It is only defined for mod x less than 1.
Oh, okay.
Okay, for large values, the series will be divergent and this will not be approximate conversion of log of 1 plus x.
Okay, sir.
Okay, so coming on to combinatorics, so how many regions is a plane divided into? If there are, let's say, n lines, no two parallel, no three concurrent.
Sir, I am using the pen and paper system.
Sorry?
Sir, I am using the pen and paper. So, should I say orally?
Now you can solve it and then
Okay, sir.
recite.
Sir, I think the answer is n choose 0 plus n choose
Hmm?
1 plus n choose 2. Like 1 plus n plus, yeah, n choose 2.
There are n
Like,
lines.
and yes, there are n lines.
Okay?
So I can prove it by I can prove it by induction. So
Hmm?
if it happens for like say it is true for any general k, then if I add another line k like like the k plus 1th line, so it will cut all the other k lines at k points, k distinct points. For every one of these points, there will be uh, one region added. So by adding those, yes, so as there are no two parallel lines and no three concurrent lines, so there will be distinct k points where it cuts the other k lines. So there will be another k regions for these intersections. So
Okay,
by
so
adding this,
let's start with two lines.
yes,
So for n is equal to, there are four regions. Okay,
so
so if we add the third line, the third line is going to cut the first two lines at, let's say, point 1 and point 2.
yes, sir.
So let's say this was region A, this was B, this was region C, and this was region D. So how many regions got added?
Like so in this case, three regions were got added.
But you said a line would intersect at 2 points,
Oh,
right?
sorry, like at 2 points. So that would imply that there will be k plus one many, like if there is at first k lines and I am adding one another line, so
Hmm?
it will intersect at k many distinct points, the other k lines.
Yes.
So it will add k plus one more regions with the previous ones. So by by then doing some algebra, I can like get the following. Like I can prove the induction. N choose 1 plus n choose 2 plus
Okay,
n
so
plus 1.
so where does this come from initially?
I actually read it in a book, and I solved it using this induction method only. There was a statement written in the book, but I was unable to understand.
Can you try using counting? For example, n is equal to 1, the number of regions is 2.
Hmm.
N is equal to 2, the number of regions would be 4.
4,
N is equal to 3, it is going to add how many
3
regions?
regions,
3
3
regions.
regions, 7.
N is equal to 4, it is going to add 4 regions.
Yeah.
N is equal to 5, it is going to add 4 plus 3 plus 4 plus 5 regions.
Like by recurrence, I think we can also solve it.
Okay. So talking about recurrence, can you derive the recurrence formula for dearrangement? Did you know that dearrangement is a recurrence? It follows a recurrence pattern.
Yes, sir. Like dn is equal to n. I don't know the exact formula, but I think I can prove the recurrence.
Yeah, try to do that.
Sir, can you please tell me the recurrence? I actually forgot it. Like,
So dn is equal to n minus 1 times
yeah,
dn minus 1 plus dn minus
dn is okay, sir. Sir, one thing I could do like suppose there are n letters and n boxes for these n boxes, and as it is the rearrangement. So suppose
1. Hmm.
yes, sir. So suppose in the first box, like in like the set B, I am it is the boxes, and the set A is the letters. So some kth letter is going to the first box,
Hmm.
and the first letter in going to the uh, kth box.
Hmm.
Yeah. So there will be remaining n minus 2 boxes and n minus 2 letters. So for this, I will get a rearrangement of dn minus 2.
Hmm.
And fixing this one, the k can vary up to 2 to n. Like there are n minus 1 choices. So
Hmm.
there will be n minus 1 into d n minus 2. But I couldn't prove for the d n minus 1 part. Like
So let me make things simple. Let's say there are 4 elements in set A, 4 elements in set B,
yeah.
and you have to make functions from A to B such that f of I is not equal to I. Okay, so basically I'm talking about dearrangements.
Mhm.
So how many functions will be there such that f of 1 is going to be equal to 2? F of I is not
If
equal
of
to I,
1
but f of 1 is 2.
if of 1 is equal to 2, then 4 cube, there will be 4 cube other functions. Like for
But f
2
of
I
I
have,
should not be equal to I.
oh, okay, if of I should not be equal to I, then
So it is basically dearrangement of 4 objects only. But I'm fixing the first object. First object is
yeah.
anyways not going to go to 1. But I'm fixing it
Hmm.
the place for first that f of 1 is 2.
So it will be rearrangement of 3. Like if of I,
Will it be dearrangement of
no,
3?
no, 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 so sorry. Like 1 is going to 2, then
So
rearrangement
basically
of
what
if 2 is going to the place of 1, then we will have a rearrangement of 2.
basically 1, 2, 3, 4. If 1 goes to 2, we'll have the case when 2 is going to 1. So it
Yes,
is dearrangement of 2 objects.
yeah.
And case 2,
If 2 is not going to 1,
1 goes to 2, but 2 is not going to 1. So if 2 is not going to 1, so we can place 1 in front of 2, 3 in front of 3, 4 in front of 4. So can I say it is going to be dearrangement of three objects?
Yes, sir. Yes, sir. Yeah.
Okay.
Okay, sir. Got it.
Now, right. So this is D2 plus D3. Now, can I say if this was not the condition, 1 going to 2 was not the condition, then it would be D4. There were 4 objects to be dearranged following this condition. Now, out of these D4 objects, can I say, of course, 1 is not going to 1. But again, in some of the cases, 1 is going to go to 2. In some of the cases, 1 is going to go to 3. In some of the cases, 1 is going to go to 4. So, number of ways in D4 where 1 goes to 2 is same as the number of ways in D4 where 1 goes to 3. And it is going to be same as the number of ways in D4 where 1 goes to 4. So can I say this is actually equal to D4 by 4 or D4 by 3, sorry.
Yes, sir.
1 goes to 2 is going to be equally divided amongst 1 goes to 2, 1 goes to 3 and 1 goes to 4. So we have D4 is equal to 3 times D2 plus D3. This is nothing but this formula only. So same thing you can do
Yes,
for
sir.
X. Okay.
Yes, sir.
All right, SOUMABHA, so let us end here. So I think you were good. It was nice. Last time also I'm seeing the remarks. It was good. So overall, I think you should be able to do really well. When is your interview?
Sir,
24th.
24th is this Saturday.
Okay. Okay. Did you get selected in CMI?
Yes, sir. I have got selected.
You are?
Yes, sir. I have.
Okay. So what would be your first choice?
Like, sir, if I got selected in ISI, then ISI will be my first choice. If not, then CMI. There is.
Okay. Great. So overall, it was good SOMA. So I have,
And
I mean,
sir,
this,
is
yeah.
there any portions that I should work on now?
Uh, one is you should know, first of all, your answers of UGB, what you've written.
Yes, sir.
And of course, the question that you are not able to do, if you can, I mean, have a look at them, those questions. All right. So if they ask, it might, put a good impression on them that he did not even stop at ISI exam. He went further and solved the question that he was not able to solve the exam.
Okay.
Right. So that is one. Maybe you can, if you can find some alternate solutions to the solutions that you gave in the exam, that also. All right. So that is one. Number two, uh, the feedback would be to keep smiling. You don't smile, right? So it does put a good impression, right? So they want people, of course, who are good in mathematics, but again, who are also smiling, right? So
Okay, sir.
keep on
I will
smiling
smile.
in between the questions, right? So that is another thing. Otherwise, as far as mathematics is concerned, I don't think there's an issue there. You should do really well.
Okay, sir. And sir, one thing, they actually
Hmm.
asked a certain question that why would you choose statistics like I applied for B.Stat, statistics over mathematics? Then how should I approach this question?
Why did
Actually,
you actually choose statistics?
like to be honest, I am from Kolkata and
Okay.
ISI Kolkata is very near to my house, and
Okay.
that's the preference. And nowadays statistics has more career options than mathematics, and like
Hmm.
applied mathematics in the question.
Yes,
So
you can say that. You can say that applied the mathematics you were interested rather than pure mathematics, and this is the only
yes,
answer. I mean, there is no other answer, right? So at the end, of course, they're also humans, and they also understand that people who are staying in Kolkata are bound to choose ISI Kolkata over ISI
yes,
Bangalore, right? Because this happens not only in ISI but also during IIT selections.
yes,
So
yes,
people in South they prefer IIT Bombay even if it compromises on their branch. People in East side they prefer IIT Kharagpur, right? So
yes,
I mean, they all know that they also have their children and they also have to make these kind of decisions, right? So you don't directly say it, but again, they would understand,
Okay, sir. Sure. Okay, sir.
right? So all the best, Soumabha, and I'm
Thank you,
sure
sir.
you're
Yeah.
going to do really well in the interview and come out with the flying colors. So once
Yes, sir.
you are out, and again, yes, this kind of smile I want you to do more in the interview. And once you are
Okay.
out, we'll have a small session just to motivate the juniors.
Okay, sir.
And maybe
Certainly.
next year for our batch, ISI batch, we'll have a couple of lectures. I'm sure about a couple of students who are definitely going to make it. You being one of them. So we'll have a special session with the students who will be a part of the ISI batch in Vedantu
Okay, sir.
to share the
Sure.
experience. So all the best, Mr.